ready.
Yes. Okay. Odds ratio. A student conducts a case controlled study to evaluate hypertension as a risk factor for breast cancer in women. Case 9, case n equal to 20 are defined as women with histopathologically confirmed primary breast cancer who are recruited within 2 months of diagnosis. Incident cases and controls n equal to 20 are defined as women who have no evidence of malignancy in images during screening mammography completed 6 months prior to recruitment, and women and who have no personal history of breast cancer. Blood pressure is more than 140 over 90 millimeter of mercury and is used as a cutoff point to identify as hypertensive. The student estimates an odd ratio 4 and confidence interval 1.75 to 9.12. This is clinically significant, this confidence interval.
Mm-hmm.
Okay. And concludes that the women with hypertension have fourfold greater risk of breast cancer than women without hypertension. Based on this information, which of the following describes the reason that the student's conclusion is incorrect? Incorrect. Uh, is C is incorrect?
What? I can understand. What do you think is the answer? I can understand
C,
what you're saying.
the option A, because there is it is statistically significant, isn't it?
Yes, you just said it. Yes.
Because there is not shown. So A is the answer. Is not
What's
in.
the
Sorry, not incorrect. That means
wait?
correct.
What do you? I don't understand. What do you think is the answer?
Sorry. Wait. The student's conclusion is incorrect. So we will find the incorrect option.
Okay, the question. Read the question. Is asking which of the following describes the reason that
The
the
conclusion is
student conclusion
incorrect.
is. So basically, they are telling you that the student conclusion is wrong, but now they're asking you why is it wrong.
Okay. Is it option A?
Okay, you think it's A. I think it's D.
Okay. Let's see.
Let's try to, before
Exclude.
we look at the
Yes.
answer, let's try to think. Okay, A, you said because the association is not shown to be statistically significant. But you just said that the association was statistically significant.
Significant.
Why?
Yes.
You just said it. So this cannot be the reason why is it incorrect because you just say it's significant. 4 is included in 1.75. Yes, it's included.
And
And
it
then it's also, and it doesn't include 1.
one.
So this is statistically significant. This telling us that it's not statistically significant. So this is not true because we know it's statistically significant.
Because the confidence level used is incorrect. What does it mean? Because the confidence,
Confidence level, confidence interval, whatever. You
i-
cannot. They didn't give you no confidence level here. They just say confidence interval,
yes,
95%. So this doesn't make sense. They didn't give you no confidence level here. And then it says because the confidence interval for the odds ratio includes one, includes four. Yeah, it should include four, so that's good. That's not a problem. That's not the reason that the study will be wrong. It should include four in this confidence. If it didn't include four, then it will be a problem.
yes, it
So that's
includes
good.
four. Yes,
So that's good when it equals four. So all of those are we already taken them out. The only thing is left is this one because the measure of effect is not a direct measure of risk. Look at what we are using here, odds ratio. And
yes.
remember yesterday what we said? Remember we said,
Case control, like in case of odds ratio.
yeah,
Mm,
remember that we were saying that odds ratio is for odds and risk ratio is for risk.
yes,
Yeah. So here, the conclusion they're saying, the conclusion that the students are saying here is that woman with hypertension had fourfold greater risk of
yes.
breast cancer, but they are using odds
Odds
ratio. So why
ratio.
are they bringing up risk?
Okay.
You see, yeah.
So odds
So
ratio
that's
is
why I
for
always
odd
remember
and risk
risk.
ratio is for risk.
So the odds cannot measure the risk.
Okay. Now I got
Yeah.
it.
Okay, keep reading.
Okay. And the odds ratio is a measure of association in case control studies. In a case control studies to compare the odds of exposure in cases relative to the control. The odds ratio is not a direct measure of risk. In this case control study, in this case control study, cases are women with breast cancer and controls are women without breast cancer. The exposure is hypertension because cases in case control study already have the disease. This study design cannot calculate the risk of the disease. Instead, it compares the odds of exposure between the cases and the control. The odds of an event are related to the risk or probability of that event. Odds P divided by 1 minus P. For an example, probability, that is risk of rolling a dice. Sorry, risk of rolling a die and getting a 1 is 1 by 6, but the odds of rolling a 1 is 1 by 5. Okay. The measure of association between the exposure and disease in case control studies is the odds ratio. Odds ratio is the odds of exposure in cases divided by odds of exposure in controls. The odds ratio is sometimes described as odds of the disease among exposed patients relative to non-exposed patients. These two definitions are mathematically equivalent. The estimated association odds ratio 4 means that women with breast cancer have 4 times greater odds. Women with breast cancer have 4 times greater odds rather than the risk for hypertension than women with no breast cancer because the 95% confidence interval of the odds ratio 1.75 to 9.12 excludes the null value, odds ratio equal to 1. The results are statistically significant. Therefore, the student's conclusion is incorrect because the measure of the effect odds ratio is erroneously interpreted in terms of the risk rather than odds.
Makes sense.
Sorry?
Makes sense. Sorry.
Yes.
It makes sense. Okay, perfect. Next.
Okay. Mean median mode. Okay. In an intensive care unit, in an intensive care unit, 10 measurements of systolic blood pressure were obtained over several hours using an intra-arterial cannula. The maximum value recorded as 120 and the minimal is 100. If the next measurement shows a value of 240, which of the following is most likely to happen? The mean will not gonna increase, isn't it? The mean will be same. Um, Positive Q and negative Q. Positive
Mhm.
Q. Sorry. Median, median is the middle one and mode is the other one.
So what are they asking you? I feel like
So,
sometimes it's like I think
uh,
it's your issue with these questions is the you don't understand the question they're asking you. What are they asking you? Yeah.
yes, that's the thing I am looking
Yeah,
for.
I noticed. I noticed. It seems like you don't understand the question they're asking you. So I think that's why
If
you
it
need
is
to work on
positive
biostat. Like
Q, then it is like
no,
this is not the thing.
no, that's not what they're asking you.
If the
They're
next
asking
measurement
you
shows the value is 240, which of the
mhm,
following is most likely to happen? They are
what
asking for
okay.
what?
They're asking for okay, so so you need to figure out how you're gonna understand those questions. So here they're asking you, okay, they're giving you 10 measurements and then they're adding one.
Okay.
What's gonna happen? What's gonna change? And then there basically is the mean gonna change? Is the median gonna change, or is the mode gonna change? Is the range gonna change? Is the standard deviation that's kind of what they're asking you. So now that if you got that part, like what they're asking
Yes.
you. Okay, so what do you think? Which
L-
if you have
The mean
you have
will,
10.
yes. If I have 10 blood pressure measurement, if I add
Mhm,
one,
mhm,
the mean will
mhm.
increase.
You got it. Yeah. So I think your issue with biostat is just understanding what they're asking you. Well, I don't know how
Okay.
is yeah, it's understanding because once it seems like once I explain I tell you what they're asking, you get the answer.
Yeah.
You get the answer immediately. But okay.
That's the problem with Biostat for
Yeah,
me.
yeah, I notice. Yeah, I'm noticing now. Okay, 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 okay. Hmm.
Okay.
Mhm.
I'm reading the explanation.
Mm-hmm.
And and the other thing, that the positive skew and the negative skew. In positive skew, the mean is the lowest, then the median, then the mode.
Then it's always the same mean, median, mode.
Okay.
Mean is the lowest, whatever. So even if I do it the other way, the mean is always going to be the one that's at the tail, and then it's going to be median, mode, mean, median, mode, mean, median. I
So
just do it like to remember, you know.
mean is
And
always in
then
the tail.
mean is always at the tail, and
Okay.
then medium in the middle, and then mode. And
Mode.
then I also remember by like alphabetical order. Mean is MEA, medium is MED, D is after A, and then mode is MO, just is after. And then it also helps me remember that once you add an extra value, the mean is going to be the one that's changing the most. Then the median is going to be the one that's changing the most. And the mode is the one that's basically not changing. So the mean is going to be the more affected if when you add an extra value. Then the median and the mode is the least affected. It's kind of how I remember both things just by this, by the thing.
Okay.
I don't know if that helps. I don't know if that helps.
Yes, that helps truly.
Okay. Okay.
Explanation. An outlier is defined. An outlier is defined as extreme, defined as an extreme unusual value observed in a dataset. It may be the result of recording error, a measurement error, or a natural phenomenon. An outlier can affect the measures of the central tendency, mean, median, mode, as well as the measures of dispersion, standard deviation. The mean is the extremely sensitive outlier and easily shifts towards them, especially with small sample size. In this case, the value of 240 millimeter of mercury is an outlier and would cause the mean to increase more than the median or the mode, especially given that there was only 10 total measurements obtained prior to the value, all of which were obtained between 100 and 120 millimeter of mercury. Okay, the average mean is the value added together divided by n. Median is the 50th percentile, and the mode is the most frequent value. Okay, mean, median, mode.
And the positively
This is the
skew
positive skew. In
means
positive
the
skew,
tail is.
mean is in the tail, then the middle one median, and the mode is the toppest.
I think positively skew just means that the tail is going to the positive side, and this is the negative, and this is the positive. The tail is going to the positive. I think that's how it.
Yes.
Okay. Yeah, so this will be positive, so the tail is going there. This will be negative skew, so the tail is going there. Okay. And you see, even in the negative skew, the mean is first and median mode. Here, the mean is first and median mode, so it's always, mean median mode. Okay, so do you want to let's do this one.
Okay.
Mhm.
Find out the mean value. Okay.
Okay, you find it out, tell me which one
Yes.
what, tell me the number, I'll write it.
One mean is the median. Mean is the average, isn't it? Like one,
Mm-hmm.
we will add every blood pressure and divide by 10.
By 10, uh-huh.
Okay, I'm doing it. His median is 1289.
Sorry, I think let me calculate. I don't have no paper to calculate it here. Let me see. You see
Sorry.
median. What is the? Did you calculate the mean?
Yes, mean is 128. Sorry. Mm, Wait. What is happening? I don't know why my calculator is disturbing me.
It's okay. We'll do it at it. It's 141 of point nine. It's
Okay,
okay. I have a calculator.
one
141.
130 plus 142 plus 140 plus 150 plus 140 plus 134 plus 155 144 140 plus 141.9. Yes.
Okay.
Now
Okay.
the
You're saying
median
that, yeah, what you said the median is?
is 134 140 140 142 144 24 150 23 1 2 3 6 7 8 short watch 140 হলে দুইটা 144 140 144 দুইটা 1 142 144 2
You say
130.
it's one word?
Wait 1 second please. I don't know
Okay.
what I
Okay.
am doing.
Oh,
It is very simple calculation, I know it, but I am making it harder. 130
wait, do you know how to find the median though?
yes.
Okay. Okay.
130 140 140 140 142 150 155 Is it 143?
I don't think so.
Sorry,
I don't think so. How did you calculate it? Walk me through it.
sorry. I arrange it in the sequential manner.
Mm-hmm.
Then, as it is the even number, so I found the middle two divide by 2.
Okay. Give me your sequence. What was the first? Tell
One
me the
thirty,
numbers.
130,
Mm-hmm.
134, 140, 140, 142, 144, 144, 150, 155.
You only gave me nine numbers, or is it me? Am I missing some? Yeah, you only gave me nine numbers.
Okay, 130,
Uh-huh.
then 134,
Uh-huh.
then 140,
Mm-hmm.
140.
Mm-hmm.
There is another 140, sorry, 3 140.
Wait, there is three 140s. Let me see. Yeah, there is three 140. Sorry.
I missed that part too.
Okay.
So 3 140, then 142, 2
Mm-hmm.
144, then 150, and then 55.
Mm-hmm. So the middle two numbers are
So middle two numbers are just cross first one and last one. If you go through like this, then you will get the middle number easily.
okay. So once you get the middle number, I get 140 and 142 as the middle number.
So
Is that
then
what you get?
140 plus 142 divided by 2.
So what does it give you?
140 plus 142 divided by 2. 141.
Okay. That's what I got to. Okay. And what's the mode?
Mood is the most frequently coming number. That is 140.
That is what? Sorry.
140.
140. Okay. And then last question.
11th patient added with systolic blood pressure of 170. How will average be proportionally affected? What does it
Do you
mean?
understand what they're asking you?
No.
They're, they're basically saying average. You just read the thing. It says the average. When you were when you were reading the mean, you said that the mean is the average. So I'm thinking they're asking if you add another systolic blood pressure 170, how would that affect the mean? I'm
Like
thinking
I
that's
will
what.
uh, uh, the all the numbers plus 170 divided by 11. That's how we will
Uh,
calculate the mean and the
yeah, yes. So do you think the I think they're asking you if it will increase, it will decrease. I think that's what they're asking you. I don't know if they're asking you to do the calculation again. Yeah, maybe I guess you can do the calculation again, but I think they're asking you if it will increase or decrease.
it will increase, isn't it?
It will increase. Okay, I think so too. Okay, let's check the answers.
Okay.
So yeah, it will 141.9, that's the mean, we got it. Median 141, we got it. And most frequent value 140, we got it. And then it's telling you, okay, the mean will increase more than the median, and the mode will be the last one that's not going to really be affected. So yeah, we got
Okay.
it.
The very simple
Next,
calculation.
very
I
simple
failed.
calculation.
I failed
No,
to
you
do it.
no, it's like you don't you know what you. It's just that the for some reason it's the question that you it's hard for to get the what the person is asking. But once you know the question is like you do it. You do it without a problem.
Okay.
Yeah.
Okay. Relative risk reduction. Relative risk reduction, one formula is 1 RRR equal to 1 minus relative risk, isn't it?
Uh-huh.
Okay. A group of researchers conducted a randomized control trial to evaluate the benefit of a nutritional intervention for prevention of gestational diabetes mellitus in a pregnant woman with severe obesity, BMI more than 40 kg per meter square. A total of 800 women with severe obesity and in their first trimester of pregnancy were randomly assigned to the nutritional intervention treatment group or the no nutritional intervention control group. In addition, information packages on how to maintain physical activity during pregnancy were given as GDM prophylaxis to some participants in each group. An excerpt of study results is shown below. Among women with physical activity prophylaxis, which of the following is the closest relative risk reduction? Which of the following is the closest relative risk reduction of GDM provided by the nutritional intervention compared to the control? Relative risk reduction of the GDM provided by the nutritional intervention compared to the control. Among them, no physical activity prophylaxis. So, no physical activity. No physical. Among them, no eight, one, 400, 21, 400, 8 by 2, 100. So, 1. Is it 60%?
That's what I think so too. How you got it?
Okay. In the question, they
You want
said,
me to?
okay.
Mhm.
First, I figured out the relative risk. They are
Okay.
talking about no physical activity prophylaxis. No
Mm-hmm.
physical activity. So no one is 8 by the study group, 8 by 200 divided by the no one control, 20 by 200.
Mm-hmm.
8 divided by 200 over 20 divided by 200.
Okay.
So
That's
that's how I find it out. The 8 by 20.
okay. So what was the answer here for the relative risk that you got?
So if you like 8 by 20.
Oh,
uh,
okay. You want me to do the? I can
no, no,
do it.
I'm doing the calculation. I
Oh, okay.
calculate everything in a very
Messy one. I know. I get it.
okay. Wait, 8 divided by 20. Point 0.4. 8
Point
divided by
four.
20 is point 0.4. So 1 minus point, point 0.4, right? Point 0.4.
Point four.
So
So
1
that would
minus point 0.4 equal to point 0.6 equal to 60%.
0.660%. Okay, let's check. You are, oh, yeah, it's right. It's 60%. Okay. I didn't calculate it like that, but yeah, I got to 60% too. But that if you get it like that, that's perfect. Next, read the explanation.
Okay, I'm reading the explanation. Relative risk reduction RRR. There is a movie called RRR
Oh
who
Jesus.
got Indian movie. Truly,
Oh really?
they got the in one of the category they got the Oscar. Very boring movie. Okay,
No way.
your tutor may know that. Okay, your tutor is from Pakistan, isn't it?
Yeah, it's from Pakistan.
So he might not know it. As I am a versatile person, I know every history. Okay. Relative risk reduction describes the difference in risk of an unfavorable outcome, that is gestational diabetes mellitus, between a treatment group, that is nutritional intervention, and a control group, that is no nutritional intervention, relative to the control group. uh, Relative to the control group, that is proportion of decreased risk due to treatment compared with the control group. RRR is calculated as follows: relative risk reduction, risk control, minus risk treatment divided by risk control. The study evaluated the benefit of a nutritional intervention in preventing GDM in pregnant women with severe obesity. Participants were randomly assigned to the intervention treatment group of the or the control group. In addition, some patients received information on physical activity as prophylaxis to determine the RRR of GDM provided by the nutritional intervention compared with the control among women with no physical activity prophylaxis. Only the data for women with no physical activity prophylaxis should be considered. Based on these findings presented in the table, risk control and risk treatment are as follows: rate of GDM in the control group with no physical activity prophylaxis, risk control 20%, 0.20, and rate of GDM in the intervention group with no physical activity prophylaxis, risk treatment 8%, 0.08. Therefore, RRR of the GDM in the intervention group is calculated as RRR 0.20 minus 0.08 divided by 0.20 equal to 0.60, 0.6060.
That's the way you did it.
Okay.
Okay.
You have done in this way, isn't it?
No, I did. You know how yesterday we saw another formula that said that RRR is
Risk
uh
exposed versus unexposed.
no, it was like the formula we saw. It was ARR over control rate.
Yes,
Remember we saw that formula yesterday?
yes.
So the control the ARR would just be 20 minus 8. The ARR is just because the ARR is just the percentage, and you just subtract
20 minus 8 is
subtract
equal to 12.
12, and then you divide it by the control rate. The control was this one, the 20. So you divide it by 20, and
12
it will
by
give you
20.
and it
Okay.
will give you zero point 0.6, and that's how I got the 60.
That will give what?
Zero point
Six.
0.6,
Okay.
0.6, sorry. Zero point 0.6.
So
And
relative
that
risk reduction is ARR.
ARR over control, that we had the question like that yesterday, and that's how I got the
Yes.
formula. And for me it's just easy because ARR is always, they kind of always give you the percentage for some reason. So it's easy to calculate the ARR because it's just the percentage, you just the percentage of the control minus the percentage of the study of the treatment. So it was
Yes.
easy to get. Yeah, I just, for me, it just saves time. But the way you did it is also a way to, like, if
No,
it's easy
we
for you to
know.
remember.
I need to know the shortcut. Your one is
Yeah.
very good.
No, but yours, you did it quickly also for some reason. You probably
I
know the.
calculate in my mind very
Oh
fast.
yeah,
That's why.
because you did it fast also. So I was like,
I
okay.
haven't used like for you. I just use the calculator, but for me, I just cross out like and figure out
So you'd
what.
like to do it with your, oh my God, I don't know when was the last time I did something with my mind, with math. With math, I was to calculate. I went to calculate it.
Okay,
Okay, next.
we should go to China to learn this type of things. They are
This
very
type of,
they know these tactics very well.
yep.
Yes. Okay, we are out of time. There is no time of doing this. Okay, study design. A group of researchers plans to conduct a case control study to evaluate the association between the colorectal cancer and the evidence of past use of weight loss treatment drug lorcaserin. Which of the following corresponds with proposed study design? Case control study. What is the answer? Is it C?
Give me, what do you think is the answer?
C.
C, I think it's D. Now let's go. Did you understand the question before we start? Did you understand?
No.
What is the question asking you?
Which of the following corresponds with the proposed study design?
Now in your own words, because that you just read it. So what do you think? You think they're asking you?
I don't know why what they are asking. I think that they are asking about
Mm-hmm.
uh, why
Mm-hmm.
case control study is proposed here.
Okay, we can say like that, but they already tell. Okay, we can say like that. I think they're asking you. They already told you it's case control, so they're asking you, um, based on, after you read the maybe it will help after you read the answer. I think they're asking you, how do you how would you select the participants?
Okay.
You know, they already told you it's case control. So in case control, how do you select the participants? I think that's why. How do you set up the design? Now that you already know, we already told you it's case control. So how would you select the participants? I think that's kind of what they're asking you.
Okay.
Okay. So now answer. Give me an answer. What do you think is the answer? I've already told you, but yeah.
Case control is like the disease versus non-disease, isn't it? So we will
Okay.
select the patient,
Mm-hmm.
the patient who are having low casein with colorectal cancer, and the patient without colorectal cancer who are having low casein. Am I right?
Okay. 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 Yeah. I think yes. Yes. So what would be the answer?
The frequency. So either C and D. The frequency of the colorectal cancer should be compared in individuals with or without a history of low casein use at the beginning. Okay, no. The frequency of prior lorcaserin use should be compared among individuals with or without colorectal cancer. Okay. The
D. Okay.
okay, case control is we will see exposure to outcome, isn't it? Sorry,
No, that's
outcome to exposure.
exposure. Okay. Did you you got it? Do we need to go over the other answers
No,
or
no,
you?
no.
Okay.
Other
Perfect.
option that does not fit with this
Okay.
thing.
Okay. Perfect. I think you got the way you explain it. It makes you got it. Okay. Explanation. Oh yeah, we got this D. I guess that's the only explanation here. You can read it.
A case
But
control study is an observational study design. It begins with individuals who have the outcome cases and compares them with individuals who don't have the outcome controls according to a history of exposure to one or more than one risk factor. Okay,
okay, you got that point right.
yes,
So I think for me, it's easy to remember. It's easier to normally people start with the exposure. So you smoke, for example, and then you develop the disease, which is like lung cancer. But that will be the outcome. That's what people usually think in their mind.
yes,
So the way I remember
case
cohort will
control.
be the normal exposure. You smoke and you develop lung cancer. Cohort will be the other way. You start with the lung cancer and then you ask the patient, "Oh, did you smoke?" You
The
see?
case control one.
Yeah. So you will start with the disease and then you go that way. So the normal one is the cohort. Patient smoke and you see if they develop lung cancer. Case control is if this is confusing, don't just tell me to shut up because I try to give you how I remember it, but
No,
if
no,
you remember, yeah,
that's the
tell
tricks
me
I
to
need
shut
to
up.
know.
Yeah,
I
if
need to
it gets
know
more
how you
confusing,
remember things. I don't
yeah,
need
if it,
the
yeah,
book explanation because I have read this kind of explanation plenty of time. I don't get
yeah,
anything.
yeah, that's why I always try to give you because I think everybody thinks that the normal thing is you smoke and then you develop lung cancer.
Yes,
you know
true.
yeah.
And
So it,
that plans followed by cohort study, but
cohort, yeah.
yes, the
Mm-hmm.
opposite one, like
Opposite. Mm-hmm.
like you have the disease and you will
Mm-hmm.
find the exposure why you get the disease. That is
Why do you get it?
case
That's case
control.
control. There you go. So that's why case control, you start with people that have and don't have the disease. Have and don't have. And then same exposure, you ask them, so did you smoke? To the people that have the disease. And the one that don't have the disease, you ask them the same thing. So did you smoke? To see. And then the cohort, you start with people that have the exposure and don't have the exposure. So the smoker and non-smoker. And then you follow them or whatever, and you figure out, oh, did the smoker develop lung cancer? And then did the non-smoker develop lung cancer? So I think that's kind of how it makes sense in my mind. But
Yes, true.
okay. Okay, next intention to treat them per protocol. Okay.
A randomized control trial A randomized controlled trial 6-month intervention study is conducted using individuals with mild cognitive impairment, or dementia. The objective is to determine the multi-component therapy of MAX, a German acronym of motor activities of daily living, cognitive, social in daycare, leads to significant better progression of the activities of daily living and cognitive ability compared to the standard treatment. A total of 362 persons with MCI, mild cognitive impairment, or dementia took part in the trial, 280 of whom were randomized to the max group and 154 to the control group. At the end of the 6-month intervention phase, the sample consisted 271 individuals, excluding 55 dropouts in the max group and 36 of the control group. The reasons for dropping out The reasons of dropping out included death, transfer to a different nursing home, termination of a daycare, and treatment not implemented as indicated. The data analysis is conducted to follow the PAR protocol approach. Which of the following describes how the data pertaining to dropout should be treated? Conduct such analysis. This is PAR protocol approach. In PAR protocol approach, we will exclude the dropouts, isn't it?
Mm-hmm.
So we will exclude the dropout from the case and the control, both one.
Okay.
So exclude 91 dropouts from the analysis.
You asking me or you telling me? I'm waiting for your answer.
Okay, C.
See. Okay. Let's see. Yes, it's C. I guess you can, but I think you got it because your explanation was right. But you can read. I guess you can read. Yeah, read the explanation.
You want to say something? You want to add something
No,
regarding
no,
this?
no. I think you got it. The drop. Well, sorry. The per protocol, you exclude the persons that drop out, and intention to treat, you keep the persons that drop out. Yeah, I think the way you explained it was good. Yeah.
Okay. PAR protocol analysis compares the treatment groups in a randomized trial by including in the analysis only those participants who are strictly adhered and completed the protocol. Dropout may bias estimates of the treatment effect. For example, in a placebo-controlled randomized trial of a new drug treatment versus control group, adverse effect may cause a greater proportion of sicker patients to drop out from the treatment group than from the control group. At the at the trial's conclusion, the treatment group may end up up with very smaller proportion of more severely ill patients than the control group. Selection bias. These results could distort the estimation of the effect of a treatment. confounding bias. By excluding dropouts, power protocol analysis provides an estimate of the true effect of an intervention, assuming a perfect scenario in which all participants were retained and completed treatment as planned. However, these overestimates the effect of intervention in a realistic, practical, clinical setting, which almost inevitably includes dropout. In accordance in accordance with per protocol analysis, all 91 dropouts should be excluded from the analysis. In contrast, an analysis that includes all participants initially allocated after randomization, regardless of what happens during the study, keeping 91 dropouts in their respective groups of analysis, follows an intention to treat principle. Intention to treat analysis could be lead to conservative estimate of the effect of intervention. However, because it closely and mirrors the expected number of the dropouts in a sample situation, ITT analysis reflects the expected effect of the intervention in a realistic clinical setting. Okay. Okay, can we take a break for 5 minutes?
Okay, perfect. Oh, where am I? Can you see my screen? Okay, where is this thing? Oh, right here.
Yes, I can see your screen.
I think this you would have probably you seen that in one of the pictures, right? And one of the videos, sorry. Those ones. This thing.
Yes,
Yeah. Do you want me to go over it or you got it?
you go over it.
Okay, the guy was just saying basically the per protocol versus intention to treat. Intention to treat, you see you start with five people here, so five green squares and five X's here. So intention to treat, you will just keep them in the same place. Yeah. Even if there is a drop up, you just keep them in the same place. You see, he said that this one drop up, but you still keep them
Yes,
here.
yes.
Uh-huh. The key of the intention to twin and why is better than protocol is that it preserves randomization. Yeah, it preserves, and that's why it's better than per protocol. So just remember that intention to treat is always better than per protocol. And then the per protocol, you see these two people, these two green squares were here, and then they switch here. Then the X was here, and then they switch here. Whatever, there was a bunch of switching. So it compares the group based on the treatment that they really obtained. So the X will be on the placebo, even if it was initially here, and the two green squares will be here, even if they were initially in the placebo. So the problem here is that the randomization is broken, and so it can introduce confounding factors. So that's why per protocol is not good, whatever. And then the meta-analysis, he was explaining how meta-analysis is a bunch of studies that are put together to come up with a big combined study. So the meta-analysis can be not non-significant and significant. I mean, the studies that you are putting together to form the big one, some of them can be significant, like this one, some of them can be not significant, and you put them together and it gives you a big one that is significant. So the big one is always more significant than the little ones that are put together. That's what he's trying to say. And then you already know that when you increase the sample size, you decrease the error, and and you make the interval narrower, so close together, the confidence interval. So yeah, I think that was it with this one. Okay, next.
Okay.
You got it? That
Yes.
thing?
I
Mm-hmm.
only the problem in the meta-analysis. I don't got.
Okay.
Okay.
Uh, Meta-analysis is just that you take a bunch of studies. So let's say you did a study, and then I did a study about whatever lung cancer and smoke, and I did it in 2010. You did the same one, not the same one, but another study in lung cancer and smoke in 2015, And then my tutor did another study of lung cancer and smoke in 2020. It's different years, different people that we don't know each other, whatever. So then we are in 2030 now. And
Yes.
then somebody wants to do the same thing, study about smoke and lung cancer. But they don't want to start from the beginning and follow up and do like the case control and follow up people and no one. So they decide, you know what, I'm going to take the study from Maria, the study from Omar, and the study from whatever the tutor. I'm going to put them together, see what Omar found, what Maria found, whatever. Even if my study was not statistically significant at the end, yours was maybe, the person just puts all of them together and comes up with his own study. That's a mixture of mine, yours, and the tutor. Comes up with a big study about smoke and thing. And they conclude, yeah, smoking causes lung cancer, whatever. That's his overall study. So you see, he combined ours, and
Yes.
put together, yeah, his, whatever. So they're saying that usually the big one, the one that person did that combined all of us, is usually statistically significant. Even if the single ones, yours maybe was not statistically significant, mine was, the tutor was, whatever, it doesn't matter. The overall one, the one that the big one that combines, is usually statistically significant. That's what they're saying. Because it has more people. It has your people, that your participants that were in your study. Let's say you had 5 participants. I had 10. The tutor had 20. So the big one is going to have 5 plus 10 plus 20. So whatever, 40. I don't know what. Don't tell me to do a
No,
calculation.
no, no.
But
I
yeah,
got the idea.
yeah, he's going to have more people, so that his results are going to be more statistically significant. It's going to be less error and stuff because he has more people. Even if he didn't really follow the people, like but he just took combine our things. That's what meta-analysis is. Just combination. One person takes a bunch of study and put them together.
Okay.
Yeah. Mhm.
Okay. Can you give me 5 minutes? Oh, there is an
Yeah.
null and p-value. A group of investigators conducted a randomized placebo controlled clinical trial to assess the effect of new aldosterone receptor antagonist on the progression of chronic heart failure. The primary outcome was all-cause mortality. A decrease in all-cause mortality in the treatment group was reported with the relative risk 0.71, p-value 0.001. Which of the following statement is the best interpretation of the reported association? This p-value is clinically significant, isn't it?
Yeah.
Okay.
Jesus.
Is it option C? I think that it is not B, D, E. The results obtained are not statistically significant. It is false. It is statistically significant.
Okay. I can take that one out.
Okay.
Mm-hmm.
There is only 0.1% chance the relative risk calculated is biased in favor of aldosterone receptor antagonists. It is false also,
Which
isn't it?
one are you reading?
The
Oh,
option D.
sorry, D,
So there is only 1.1% chance
Mm-hmm.
that the
Mm-hmm.
relative risk calculated is biased in favor of aldosterone receptor antagonist. Is it? It's false too.
Mm-hmm.
Okay.
Mm-hmm.
And option B, there is
Mm-hmm.
0.1% probability observing the given relative risk by chance alone, assuming no difference in mortality. It is also false, isn't it?
That's so bad. That's why that's the thing. I don't know if that's so. Assuming no difference in mortality, there is without having the, that seems like it will make sense. Okay, read C.
There is 71% decrease in all cause mortality in the new aldosterone receptor antagonist compared to the placebo group.
Oh, so you're trying to say that this 71 is
Yes.
like the 71%?
Is it is this
Not really. Not. I don't think so.
okay?
But it makes sense. It makes sense.
Yes, I'm
And then
trying
A. Mm-hmm.
something that fixes. Okay,
Yeah.
the
Okay,
95% uh, confidence interval for the relative risk
that
for
one is not true.
yes.
That one is
So
not true.
it is either
Okay.
B or C.
Oh, C. I think B. Let me go with B and you go with C. Let's see.
Okay, let's see.
Ugh, what is the answer? It's B.
Okay,
It's B. That yeah. Now let's see
okay.
the answer
First,
first.
describe this calculation, then I'm
Um
reading the explanation. Or I read the explanation, then you make me understand.
that's in this calculation. Yeah, it's from the videos. Confidence interval, diagram, and p values. Oh, I think here he was just saying. I think he started with here, and he was just explaining this formula. This is just a formula you need to remember. And he was just explaining 95 confidence interval equals point estimate plus or minus the standard of error times 1.96. And he was explaining that the standard of error is equal to standard deviation over the square root of the sample size. And then the 196, he was saying that 196 represents the 95% confidence set intervals. So the 95% of the data that lies within one standard deviation. Remember that curve thingy, that one thingy, that normal
Yes,
distribution? Yeah, he was just saying that that 95 comes from the two standard deviation of the distribution. And then he said that this you already read it somewhere. Sample size increases, the error decreases, the confidence interval becomes narrower, and the power increases. The power goes with sample size. So when you have more participants, the power
will
of the
rise. Yes.
yeah, that one. Yeah, then he went to this. He said that the null hypothesis just means that there is no difference between the two groups. So even if you give the placebo, even if you give the placebo and the treatment, you give the placebo to one group, you give the treatment to the other group, there is no difference. The treatment doesn't do anything. That's what he was explaining. That's what the null hypothesis means, that X equals to Y. There is no difference between placebo and treatment.
Okay.
Um, and then he said that, oh, how to find the value that's not whatever. The one that we also always say that the one is not included in the confidence interval. So this is not statistically significant. This is statistically whatever. It's not statistically significant.
Yes.
Remember we always say that.
Yes.
Yeah. So he was saying that for relative risk and OR is one. That's the one we know. We always say no, one is not is included, so it's not statistically significant. But it comes from X over X. So let's say X is one, Y is one. One over one is one.
Yes.
Okay, that's what he was saying. But he was saying that we need to be careful on the exam because sometimes they're not going to give you the ratio, the relative risk, and the OR. They may give you the means. And when it gives you the means, then the new value is zero, it's not one. So when you look at the confidence at the interval, you need to make sure that zero is not inside the interval, not one. It has to be zero
If
because
they put mean in the
if
stem,
they give means, yeah, if they don't give a relative
the
race and
risk or
OI,
odds ratio. Yes.
because for means is difference in means, so it's not x over y, it's x minus y. So x minus one, that's zero. That's not one. So that's why he was trying to make. She was like, okay, you guys remember to check on that. Here, of course, they gave you the question, they gave you the relative risk, of course, so you know it's going to be one,
One.
the null value, yeah. But if sometimes in some questions, and I saw those questions, they give you the means. So when you look at the interval, you need to make sure zero is not included. And then here he's repeating the same thing. If the interval includes the null value, so 1 or 0, the result is not statistically significant. And not statistically significant means that the p-value is higher than 0.05. That's why this makes sense.
Yes.
Okay. And then the last thing, it was this thing that he went through. Oh, I think he was just explaining the whole type 1, type 2 error. Type 1 is the alpha error
Alpha.
is also called alpha, and type 2 is also called beta. And then the main thing is power is 1 minus beta, so 1 minus type 2 error. And he was saying that alpha, the type 1 error, is always is equal to the same thing, the 0.05. You know that 0.05, the p-value that we always look
Yes.
inside. Yeah, that's the type. That's the type 1 error. So it doesn't change. It's just something the researchers have said there that if it's lower than 0.05, it's statistically significant, blah, blah, blah. So it never changes. But the beta, which is type 2 error, that's the one that usually changes. So if the type 2 error decreases, then that increases the power. And you can see it, I mean, it makes sense from here. If it decreases, then the power increases. When the sample size increases, that also increases the power.
Power increases.
Yeah. So he's basically reducing it. And then same thing here. So when sample size increases, power increases. So automatically type 2 error decreases, from this. That's why he made the table here. And then sample size doesn't change the type 1 error. Remember, I just said type 1 is equal to the 0.05. It never changes. It's something that's already set there by the researcher, so nothing affects it. And
So
then I
alpha
think it was
error is always constant. 0 point.
alpha. The only way that I think he said it on the video, he said the only way that the type 1 will change is if they tell you that we are setting a p-value of 0.01 or whatever. But usually they don't give you, usually you just assume the p-value is 0.005. So if it's less than that, then it's statistically significant. But in some questions,
In some questions, yes.
yeah. So in some questions, sorry, I'm getting to message. But in some questions they will tell you, oh, this specific researcher decided to set his p-value to zero point 0.01 instead of 0.05. But they would tell you that on the question. They say, oh, the researcher that did this experiment just wanted to change and he said that he's going to set his p-value as whatever. So that's the only time it changes, because the researcher himself decided to change the value. But usually, you've seen all the questions that were done. It's usually
Yes.
the same value. And if they don't give you the p-value, then you know it's the 0.05 automatically. That's just the standard set. Um, and then here, I think he was saying, oh, he was giving the meaning of the p-value. So when they say p-value is 0.05 or whatever, he was saying that means that 4% chance of seeing a result as extreme or more extreme by chance alone is assuming blah, 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 blah. This is usually, I don't know if you remember, we did some questions where they would give you the p-value, and then they would say, what does that mean? So this is what he's telling you. If you get a question and they give you a p-value and they say, what does the p-value mean? So you just have to, we're probably going to find one of those questions here. I'll
Okay.
remind you. But you just have to memorize this definition. So every time they
What
ask
does the
you
p value means?
what you mean, it will be the same sentence that you pick. I know we did it before, so it's probably somewhere here we will see it. But yeah, that was the whole point of this thing. You you got
Okay.
it?
Yes.
Okay.
It's clear.
Okay. Perfect.
Thank
Now
you.
you can read the explanation.
Okay. Relative risk is a point estimate of association, but it does not account for random error. It is always possible that the calculated relative risk occurred by chance. The p-value is used to strengthen the results of the study and represents the probability of observing given or more extreme result by chance alone, assuming the null hypothesis is true. In this scenario, assuming there were no difference in all case mortality between the treatment and the placebo group, null hypothesis, the probability of obtaining relative risk of 0.71 or a more extreme value due to chance alone is 0.1%. P equal to 0.001 because zero point 0.1 divided by 100, 0.001. The commonly accepted upper limit cutoff point of the p-value for a result to be considered statistically significant is 0.05. P is less than 5% and is statistically significant. Okay, educational objective.
Mhm.
The p-value is the probability of observing a given result due to chance alone, assuming the null hypothesis is true. A result is generally considered statistically significant when p-value is less than 0.05.
Okay. Remember that definition. That's why they're telling you what the p, what the definition of the p-value is, basically. Okay. And you can read your, which one were you confused at? The C. Mhm.
Okay, C. A relative risk 0.71 shows the drug decreased the risk of mortality 29%. 1 minus 0.71, 29%.
Yeah.
Okay,
So now you know that what that means.
yes,
Okay. Okay. So remember that definition for p-value.
okay.
Okay. Next. Wait. What are they leaving that here? Uh, okay. Replies
Next,
to
yes. Two
answer
start.
this one.
Uh, okay,
Mhm.
two studies were conducted to evaluate for a possible association between the smoking and the disease X. Which of the following results? Study 1, odds ratio 2.4, 95% confidence interval 0.8, 4.0. Study 2, odds ratio 2.5, 95% confidence interval 1.6 and 3.0. What is the likely difference between the two studies? Is it 0.8 to 4 or
Mhm. Sorry, 0.8 to 4. Yes.
so this confidence interval includes 1. Is it clinically
Mm.
insignificant? Is there anything
Okay.
like that?
Okay. That's why you think, okay, that there's, you think that this one is
Cli-
insignificant.
yes,
Okay.
and study 2 does not belongs to 1 and the 2.4 that this odds ratio falls in the 1.6 to 3.4. So study 2 is clinically significant.
Okay. Okay. Let's see what they say. Any other difference that you see?
Sorry.
Do you see any other difference between the two studies? Anything else that you've not that you want to add? That you want to
Mm,
add? So,
no, I don't add anything.
okay, perfect. Let's look.
Okay, let's see.
Okay, so he's saying that you're right. This one is insignificant, the other one is significant, the bottom one. You got that part right.
Yes,
And they're saying that, oh, they're explaining why it's significant. They say the study one is significant. Sorry, study two is significant. So that means that it has a lower standard of error. So we just saw up there that if it's lower standard of error, that means that sample size is
Increase in,
higher.
yes.
Yeah. So that means study two has an increase in sample size. Remember? Uh, what was that? What was that? Oh, I think they're using, oh, they are showing you how to use that formula that we just saw. So the 95 confidence interval, they just gave that to you. And then the point of estimate is the 2.4, is the same for both of them. So these two are the same for both studies. And then the 96% is, we already know it's the same. It's the 95, so it's the same. So the only thing that must be changing between the two studies is this SE, the error,
Okay.
right? Yeah.
Yes.
And error is standard deviation over whatever the,
The
no,
num
the square root, yeah, square root of the sample size. So the standard deviation, I don't think they didn't give it to you here. So, but I'm assuming it's the same for the both things. So the only thing that's changing is the n. So they're assuming that these two things have a difference because the n is different between. And since this one is statistically significant, that means that it has an increased n, so a decreased standard of error or whatever. I think they were just trying to show you how that formula works. Kind of.
okay.
Okay. Now, oh, wait. Okay, let's do this one.
a study uh, a study evaluating association between the ethanol
Ethanol.
ethanol use and disease X is performed in 100 if study was repeated with 200 patients. Increase the number of patients. What effect would be the what effect would these have chance of type 1 and type 2 error? Okay, if we increase the sample size, it
Mm-hmm,
will
mm-hmm.
increase the power, isn't it?
Okay.
It
Mm-hmm,
will
mm-hmm.
increase the power, and like type
So,
2, there is less chance of, what can I say?
okay, I'm writing what you say. It will increase the power, and then,
If there is increase the power, there is decreased chance of type 2 error.
okay, okay.
Decreased chance
Anything
of
else you
type.
want to add?
And
Uh-huh.
for type 1 error, increasing the power will not gonna affect anything.
So what will happen to type 1 error?
Type 1 error would be as same as it was before.
Okay, no change. Okay,
Okay.
let's see. What you said is true. Oh, sorry. Let's see. So type 1 error, no change. You got
Okay.
it.
Yes.
Type 2 error, failed to reject, blah, blah, blah. Power increase, that you said, and sample size increase. You're right. So type 2 error will decrease. You got it? Yeah,
Yes.
you got it. Oh
Okay.
Jesus, I can do that one myself. But okay, try that one.
A study is performed and yields a p-value is 0.08. Put the result into the words and provide an interpretation regarding significance. So it is that one you told me to remember.
Yeah, that one. Let's just read it because I don't remember the words by words myself. Okay, chance of seeing 8% means that,
0.8% chance of seeing a
yeah,
result
mhm.
as extreme or more extreme than one obtained assuming H not true.
Null hypothesis, yeah, not being
Yes.
true.
So 8,
And they say that,
yes.
and they say that is higher than 0.05, so it's not statistically significant.
Okay.
Okay. It's just this is just, I think, when you see the question you will know what they how they're asking that. It's just remember a definition. Let's see. Okay, okay. Do that one. I don't know if it continues. Okay, do that one. I guess.
A study is performed to evaluate a new antihypertensive medication. The mean systolic blood pressure among patients receiving a placebo was 128.8, among patients receiving the medication 124.4. And difference the means is 4.4. Confidence 95% confidence interval 0.6 to 0.80. What is the likely p-value and statistical significance? It is statistically significant. Uh, no, not statistically significant, because 0.6 to 8. So it belongs to, sorry, it takes 1, isn't it?
Think again.
0.6 to 8.0, isn't it?
Mm-hmm.
In this range, there is 1, presence of 1.
Mm-hmm.
So that's why it is not statistically significant.
Think again. Look at
So,
this.
okay, they are talking about mean x minus y equal to 0. X minus y equal to 0. What is the x? What is the y?
You don't need to know the x and the y. You know that you're looking for
For
you
0.
is
Oh,
zero.
so it
Yeah.
is, so it is statistically significant because 0.6 does not belong to 0. Am I
Point
right?
six to eight. Uh-huh.
It
What did you
does,
say? Sorry, I couldn't hear you.
it does not include 0,
Yes.
because if it is
So,
minus, then it
uh-huh,
includes 0.
uh-huh. So is it statistically
It is
significant or not?
significant, so it is
Okay.
statistically significant.
So what would the p-value be? Lower and higher than 0.5,
Lower
than
and
0.
p
You
value.
just said that. You
Yes,
just said that.
it is statistically significant. So
Mm-hmm.
p value, the power will be increased.
So the p-value is 0.05. So will it be lower than 0.05 or higher than 0.05?
Mm, lower than 0.5.
Okay, perfect. Okay, let's see. You see now that you know it. You just have to understand what they're asking you on the question, but you got it.
Yes.
So yeah, that's what you were saying. The key here was the word mean instead of they didn't give you no risk ratio or odds ratio. It's means. So it's the difference. So it's zero. So yes, it's statistically significant. That means that the p-value less than 0.05. You see, you just the keyword. You just have to when you read, look at the words.
Okay.
Okay, next.
This one. A large scale randomization double blind clinical trial was conducted to evaluate the effect of beta blocker therapy on the effect of beta blocker therapy on survival of patients with chronic heart failure class 4. The patients with severe heart failure were randomly assigned to receive either carvedilol or a placebo. In their report of the results of the study, the investigator included a table with baseline characteristics, age, race, prevalence, hypertension of the patients in the treatment and the placebo group. According to the table, both groups have similar distribution of these characteristics. With the information given, which of the following is the most probable? Both the groups have similar distribution. what they are indicating, what they are looking for.
You mean what is the question asking? What are
Yes.
you asking? Oh,
Like in
uh-huh.
the STEM, what they want to know from me.
You tell me, what do you think they're asking me? I'm not going to be there, so you need to figure out how you're going to understand those questions on the exam because you're either going to because are going to end up on the exam. Either you're going to skip them or you're just going to like spend a lot of time there and waste time. So you need to figure out what you want to do during the exam. Do you want to skip those or you need to figure out how to understand the question? Because for some reason, once you understand the question, it's like you give me the right answer. You always give me the right answer. So it's like we just need to figure out how you can understand the question. So what do you think they're asking here?
Are they are asking the p-value, the power?
No.
According to the table, both groups have similar distribution of these characteristics. I don't know actually.
Okay. Okay. So they're on the question, they're basically describing a study. They're telling you, okay, we found well, they don't even give you the number of participants. They just say we wanted to create a study to see if beta blocker can improve heart failure in what do you say? Yeah, in people that have really bad heart failure. So we chose a bunch of patients with heart failure. We randomly put them in two groups. One they received the beta blocker, the other one they received the. So they didn't even tell you how many patients they took. They don't even tell you that. And then they say, oh, we found the results. The results. Um, oh, but they tell you here that we make sure we match them based on age, race, so we make sure we don't get any confounders or any mistakes on that point. And then they gave you we found out the results, and they didn't even tell you the result the results if the one was better than the other. Did they tell you that? No, they didn't even tell you that. They didn't even tell you if one, yeah. So then they're asking you with the information which of the following is most probable. So they're saying you, okay, everything that we're giving you, what do you think is true or false from these questions, from these answers? Sorry, from these answers. We've explained to you how we did the study. So what do you think is there something wrong with the study? Is there something right that we did? That's kind of what they're asking you here.
Okay.
So if we go through the first okay, you know what? From that, give me an answer first before I go to the answer.
We don't know the sample size. The sample size may be inadequate.
So what's your answer? What is your answer? I don't understand.
A.
Yeah.
Option A.
Okay, you think it's A. Okay, let's go one by one. The sample size is inadequate. How do you know? They didn't give you no numbers here.
Yes.
So that cannot even be that's not even an option because they didn't give you no numbers. They basically just talking and say, oh, we pick people, we put them here, we give them this, we make sure we match them by age and blah blah blah. So they didn't give you the numbers. So you cannot deduce the sample size inadequate or inadequate or it's good or it's bad because they didn't give you any information. Here B, they said the study is negative. I don't know what it means when they say study. It doesn't make sense.
Yes.
What does it mean when it says study is negative? It doesn't make sense. The power of the study is big. Again,
They
remember
haven't.
we
Yes.
discussed
They haven't
uh-huh,
given the any number, so we
the
don't know
number, yeah. They haven't give you the sample size. Remember, the power goes with the sample size.
sample
They
size.
didn't give you
Yes.
the sample size. Yeah, so you cannot deduce the power. They didn't give you no numbers, nothing. And then they say observer bias might be an issue. They didn't even tell you what if the researcher observed something, if it was a cohort and the research followed them and the observer followed them for years, or if it was like a case control and the observer, they didn't tell you anything about the observer in the question.
So only
So
thing
this
the
is
randomization is.
randomization is the only thing they talk about. You can hear where they say, oh, we made sure we matched them by age and hypertension and blah blah blah. So they mentioned that. They mentioned they want you to make sure to mention you that, oh, we make sure that we match them. So that's how we know our results are are good, are significant, but because we make sure. So that's the only thing they talked about. So that's the only thing that can make sense here. Um,
Okay.
so yeah, that's the answer. Yeah. So basically, if it's not, I think this question it was just to make sure if it's not, they didn't tell you anything on the question about that, it cannot be an answer because just didn't tell you anything on the question about that.
Okay. Now I got it.
Okay, with the
Okay.
explanation.
The purpose of randomization is to make the distribution of all potential confounders even between the treatment and the placebo group, unlike all other methods controlling, confounding, matching, stratified analysis, randomization potentially controls as well as unknown confounders. One of the methods to assess the adequacy of randomization is to look at the distribution of the baseline characteristics in both groups. If they are similar, no one can assume that the randomization evenly distributed the confounders between the groups and the randomization was successful. Okay.
Oh, okay.
So in clinical trials, educational objective in clinical trials, randomization is said to be successful a similarly when a similarity of baseline characteristics of the patient's treatment and the placebo groups is seen. Okay,
Okay.
next.
Next, study design.
Design.
Wait, what is the question? Oh, oh, the answer to the question is here. Okay, go ahead.
Over the course of 2 days, 25 elderly individuals came to the emergency department because of urban medical center with acute respiratory tract infection, mainly bronchiolitis and pneumonitis. Public health authorities investigated the outbreak and used standardized questionnaire to collect relevant clinical and socio-demographic information from the 25 individuals with acute respiratory tract infection and 50 elderly individuals without acute respiratory tract infection, matched by age, sex, and country of the residence. Preliminary results showed that 92% of the elderly individuals with acute respiratory tract infection has had attended a social gathering with the previous week. 20% of the elderly individuals without acute respiratory tract infection had attended the same social gathering. Which of the following statement is correct about the study design? What is the answer?
You tell me. How you ask me? How is the answer? Oh my God, I can't do it. What do you think is the answer? The way you ask me, I'm like, wait, what do you mean? What do you think is the answer? Can you eliminate, or tell me which ones can you eliminate?
Because individuals with or this study is randomized control trial because it matches everything, isn't it? Option A.
Oh, wait, before we go there, the most important, what are they asking you? That's it.
Study design. About the study design, is it randomized control, is it case
Okay,
control, or is it
okay,
cohort?
okay, okay. Perfect, perfect. Okay, you got it. I think you got this. Okay. So which one do you want to? You want to? You say A. A. Do we keep it or do we eliminate it?
We should keep it
We should keep it. Okay. You think because
because
individuals.
individuals with or without acute respiratory tract infection were matched by age,
Mhm.
sex, country of the residence. These studies RCP.
So is one of the requirements of RCT that the people
Randomization.
need to, okay, okay. But so in so in case control and cohort, there is no randomization.
Usually no
Okay, I thought
randomization.
okay, I
That
thought
that flow
okay,
chart, if it is
okay,
randomization, then it is
okay,
RCT.
okay. So in cohort, the randomization we do it to eliminate the confounders, right?
Yes.
Mhm. So do we try to eliminate confounders in case control and in cohorts?
I don't think so.
Okay, okay, we'll keep that one. Okay, let's do B. Okay, you say
Oh,
you want us to keep that one, so we'll keep it. Okay,
because it collected data on the attendance at the social gathering and presence of acute respiratory tract infection using a standard questionnaire. It is cross-sectional study.
what do you think about that one?
False.
False. Why? Because
Cross-sectional. Yes.
remember what was cross-sectional study? It was we don't select the patient based on what is it, outcome or exposure. We just
Yes.
find them on the street and ask them we ask them right there and then, hey, do you have cancer? Did you smoke? They say yes, yes. Okay, that's it. We don't follow them. We don't try to study them. We don't. You know. So here it says that the public authorities investigated the outbreak and they used a questionnaire. So
Okay.
they went to the hospital. I'm thinking, I don't know. I'm not sure. I don't know which one is the answer here. So I don't. So I'm also confused on that one. So I'm thinking they went to the hospital of the where the people, the 25 old people were sick, and they started asking them right there, like, hey, so what did you do? Did you go to the gathering? They say yes. And then they found another 50 people in that same hospital that didn't have the respiratory thing, and they say, hey, did you go to that same thing? And they say no. So I'm thinking, maybe I don't know. I'm thinking this is an option. So let's put it.
Cross-sectional. Okay.
Okay. Now see.
Okay. Because it compares the information about attendance at social gathering among individuals with or without acute respiratory tract infection. This is a case control study.
Do we think this is an option or not?
No, it's not. A case control means uh, disease versus there is no such thing. There is no comparison between disease and non-disease. And in case control, there is outcome and exposure, isn't it? We will.
Okay, but here they're telling you they are giving you the 25 that have the disease and the 50 that don't have the disease. So that's outcome, disease and non-disease, right? And then they are going back to the exposure. They're asking them, oh, did you attend the party or did you not attend the party or not? Did they? That's oh, am I wrong? Maybe I'm wrong.
No,
Okay.
that makes sense, but
That makes sense. Okay, but you don't think it's this one. Okay,
yes.
let's keep going. Okay, you don't think it's this one. Okay, so let's delete it. You don't think it's this
Because it compares the incidence of the disease among elderly individuals who attended the social gathering and those who did not is a cohort study.
What do you think on this one? Is that an option that we keep
Mm,
or we just
no,
eliminate? No, we don't keep it. Okay.
yes.
And E,
Because it describes individuals with or without acute respiratory tract infection in terms of clinical and socio-demographic characteristics, the study's case series.
do we keep it or we don't keep
No,
it?
no,
We don't keep it. So the only ones you're trying to keep is A and B.
yes.
Okay, let's see. So it's C. Okay, let's see
Case
why. This
control study.
is the case control study. So read the explanation, but you also have to read A and B because we were
Yes.
confused about it.
In this study, elderly patients with acute respiratory tract infection are the cases. Individuals with disease. An elderly patient with no acute respiratory tract infection is the control. Individuals with no disease. A questionnaire was used to collect the relevant clinical and socio-demographic information to compare the exposure to one or more than one increased risk factor of interest, that is attendance at social gathering, because cases and controls, because individuals were initially selected based on their status for a particular disease, case acute respiratory tract infection, control no acute respiratory tract infection, then categorized based on the past exposure to a risk factor, attendance at a social gathering. The study is case control design. Okay, choice A. In RCT, patients are randomly assigned to one or more than one intervention to evaluate the effects of those interventions on outcomes. Participants in RCT may or may not be matched by certain characteristics: age, sex, residence to control for confounders. However, this study does not involve the comparing treatment.
Okay, before you keep it, the explanation first, do you understand the explanation only? The why is it case control and not cohort?
Yes,
You
they
get it?
made the difference between the disease, the acute respiratory tract infection, and the control one, the no acute respiratory tract infection. Then they set a questionnaire and find the risk factor.
Okay, so you understand the explanation makes sense. Why is case control and not cohort?
Yes.
Okay. Now choice A, does it make sense? Why is it
No,
not? It
I don't
is not
understand why.
randomized. Okay, remember our graph for randomized control. You remember the setup for randomized control, how it's supposed to be set up. You were right. That is randomized. That it has to be randomized. So you were right in this part. You
Yes.
know that it's random. Yeah, it's randomly assigned. But you look at the setup of the randomized control trial. You need to have two groups: the placebo, where you give the treatment, where you don't give the treatment, and the treatment, the other group where you give the treatment, and then you check for the outcome. When you read that question, is the setup right like that? Is it set up like that? Like you have two groups and you give one treatment on the other one, you don't
No,
give what?
no.
No. So it cannot be a randomized control trial. Even if you randomly do whatever, whatever, they didn't even they I think they used the word randomized in that question to throw you off, you know. But when you look at the setup, it just doesn't look like a RCT where you give medicine here and you don't give medicine here and then you follow up. It just doesn't look like it. That's what they're trying to tell you, that even if you get confused with the word randomized, the setup that they give you here is not, it's not the RCT. That's what
Yes.
they're trying to say. Mhm. Okay, B.
In cross-sectional studies, In cross-sectional study, a snapshot of population is taken to estimate the prevalence of risk factor and the disease simultaneously. A questionnaire is often used to collect data in cross-sectional study, but they are also common in other study designs. Case control study.
Does it make sense, that one?
Little bit.
So yeah. So I think the key, they trying to say that they use the word questionnaire here to throw you off. Because usually people like me, when I when I see questionnaire, I automatically think, oh, it's cross sectional. Most, yeah, yeah, a lot of people think like that because questionnaire is the only thing that you will go in the street and ask people fill in this questionnaire. So I automatically assume it's cross sectional study, but they're saying that no, that was just to throw you off because questionnaire can also be used in case control or cohort, like they use it here. So once you see questionnaire, don't just assume that hey, it's cross sectional study. That's kind of what they're saying.
Yes.
Look at the overall, yeah, look at how they set up the study, look at what they, if they started with the outcome, with the exposure, look at all that. Okay, now the red thingy.
Remember, case control studies can consider only one outcome, disease, per study, but can evaluate the exposure to one or more than one risk factors.
Make sense?
Yes.
Okay, perfect. Next, oh Lord.
A group of researchers is investigating whether the availability of green spaces, grass, forest, parks within people's living environment is associated with depression associated mortality. Data of officially confirmed deaths related to the depression during the past 10 years are collected in a sample of uh, random samples of counties across the United States. A demographic information system is used to calculate the percentage of green space in each country. During data analysis, the percentage of green spaces is categorized as low less than 25%, moderate 25 to 50, 85%, high 85%. An excerpt of the study is shown. Which of the following is the best statement in concerning the results of the study? Both moderate and high is clinically significant, isn't it?
Mm,
Nobody touches
okay,
that
yeah.
one.
Mhm. Okay.
Is it A or B?
You
I
tell
don't know.
me.
There is to be. Okay, option A high percentage of green spaces within the living environment causes significant decrease in the depression associated mortality. So high percentage, 0.760. Mm,
Do we know what, before we start, do we understand the question? Do we get it? We get the question?
no,
What do you mean? you just you just said me it was between A or B. Okay, what do you think the question is asking you?
they are asking us
Mhm.
like they are asking in between high percentage and media moderate percentage people with green space have uh, decrease depression mortality rate or not, significant decrease in the mortality rate or not. That's how I got, that's what I got.
Okay, okay, that's okay. That's one way of seeing it. But this, for me, the simplest thing, just not to think that much. They are asking you which of these sentences, A, B, which one is correct.
Okay,
That's all. Like, don't try to overthink the relative of this. Just asking you which of these statements, which of these sentences
it's
is
correct.
correct regarding this study. You know. So if you read this and you compare it to the study, is this one correct? If you read this and you compare it to it, is this one correct? That's all they're asking. Okay, so read A. Let me know if we
So high,
eliminated or
so high percentage of the green
Mhm.
space with living environment causes a significant decrease in depression associated mortality.
do we keep it or do we delete it?
We should keep it. There is a relative risk of depression associated mortality in high green space is actually decreased, isn't it? And it is in the
Look at this. Look at this word.
causes.
Can cohort and case control describe causality?
Mm,
Like can cohort or case study say, oh, smoking causes um, lung cancer?
no, no.
No, right?
Yes,
They usually is just to test to find an hypothesis or whatever.
yes.
Test an
They do
hypothesis.
not find the. They do not work with the
Find
causality.
with the cause. If you want the cause, you usually do an RCT where you follow the patients, blah blah blah. You give a drug, whatever, and all this, whatever. The RCT usually finds the cause. But case control and whatever, you just test an hypothesis. Oh, there is increased risk. There is decreased risk. There is increased odds. There is decreased odds, but usually not causality. So this one we can eliminate it just because of that word. That word is when
The
they give you those word,
co-
it causes, it's 100% true. It's just usually try to look at the answer again. Usually it's not the right answer. When they tell you it's like this, it causes this, you know, usually it's not the right answer. Okay, read B.
okay. A high percentage of green space with living environment can prevent depression associated mortality. Um,
The
false.
word prevent, I don't know what prevent. It's not causing, it's not implies causality. It just says it can prevent. So let's keep it. It's not a strong word where it's like, oh, it causes this. Just says it can prevent. And we see it, you right here, we see that high green spaces decreases depression and it's statistically significant. So let's keep that one. Let's do C. Keep going. If we don't
A-
find anything better, maybe that one is the answer.
An individual living in an environment with a high percentage of green space has significantly lower risk of depression mortality than an individual living in an environment of the low percentage of green space.
Hmm. What do you think?
True.
Okay. Did they give you the low percentage
No,
here?
no information is given on low percentage.
And is given. So how do you know that it's higher or it's low?
Okay, then it is out.
No, I mean I don't know the answer here, so I'm
No,
just
no, no.
thinking as I'm
As,
doing the
as they do not give the information, so it should not be the answer.
oh,
Like
okay,
you have to say something, forget the answer.
okay. So you want me to keep it or delete it?
Delete, delete.
Okay. Let's do D.
An individual living in an environment with a high percentage of green spaces has the same risk as a depression associated mortality as an individual living in an environment with a low percentage green space. It is also false. So
Okay.
delete.
Okay.
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 There is statistically significant association between the percentage of the green space in a living environment and depression associated mortality.
What do we think about it?
It it may be true. There is
Mm-hmm.
statistically significant.
Mm-hmm. Because we see both of them are statistically significant.
Significant,
And it
yes.
says, yeah, and it just says there is statistics. It didn't say no, it causes this or it causes that. It just said there is. It seems that there is some kind of association there. Seems like that's it. So they didn't use a strong word. So we are between B and E. You want to look at the answer or you want to pick one? Pick
Think
one.
I should
Pick
look
one.
at this. Okay, E.
E. Okay, let's pick E. You are right. It's E. It's funny. You are right. It's E.
Okay,
And but we're gonna read the B answer, the big answer because we were kind of not sure about that. Okay.
okay.
Go ahead.
Explanation. In this study, researchers collected country-level data on depression-associated mortality, country-level proportion of death certificates where depression was listed as contributing factor, and calculated the percentage of green spaces in each country to determine whether the presence of green spaces is associated with depression associated mortality. They did not collect any individual level data. This is consistent with ecological design. This is consistent with an ecological design in which the rates of an outcome, the rate of depression, associated mortality, and the exposure high percentage of green space are measured at the population of community country level and their association examined. The results suggest that compared to the countries with low percentage of green space reference group, countries with moderate and high percentage of green space have a lower risk of depression associated mortality because the corresponding relative risk RR of the 0.831 and 0.6760 are both less than zero point 0.1, both 95% confidence interval, and the RR. Okay, John. Okay, the results suggest that the compared the countries of the low percentage of the green space reference group with a moderate and high percentage, both 95% confidence interval for the relative risk excludes the null value of 0.1, null value of 1. This indicates the results are statistically significant. Therefore, the percentage of the green space in living environment is significantly associated with depression associated mortality. Okay. Although ecological studies are commonly used to generate hypotheses and may establish the association between the risk factor and the outcomes, Results from this type of study cannot establish the causality. They are also not valid for making interference regarding subjects, individuals within these population because results of other information which sorry mm, they are also they are also valid for making interference regarding the individuals with within this population because the results offer information of the population country level rather than at the subject level, choice C and D. The phenomenon is known as ecological fallacy. The fallacy assumes that individuals of the population have the average characteristics of the population as a whole, but association, but association, any association, where I am. Okay, ecological fallacy. The fallacy assumes that individuals of the population have the average characteristics of the population as whole, but any association observed between the variables at the population level does not necessarily mean that the same association exists for any individual selected from the population of does not necessarily mean that the same association exists for any individual selected from the population. That is, a subject living in an environment with high percentage of the green space may not have lower risk of depression associated mortality.
Okay.
Okay.
Does it think make sense? We good? We know why A and B, sorry, B was not, is not right, right?
Mm,
Remember?
yes.
Okay, you know what they, okay. And we know what C and D are not right also.
Yes.
Okay, perfect. The red thingy.
Okay. The red thingy. In ecological studies, the unit of observation is the population. Disease rates and exposure are measured in which a series of population and their association is determined. Therefore, results about association at population level may not translate to the subject level. Okay, what does it mean?
Okay, it says that you see here they didn't talk about it, about participants and stuff. They just said they went online and looked at the the location on whatever counties. I don't know if you guys have counties there in your country, but here it's like we have the country, and then the country is divided into states, and then the states are divided into counties, and then the counties are divided into cities. So we have like big, you know how it goes to big to small. So it's like cities. It's different cities. Let's say just live, you know. So you are not studying the part one person or like a group of people, whatever. You're studying whole big cities with maybe like a million people, you know. So is at the is a that's what ecological level means. That means that you are not studying uh, uh, one or two people or a participant. You are studying a whole big city, you know. So usually the problem with those studies is that they will say, oh, all the people that live in the Miami's, I guess Miami, yeah, I guess Miami City, um, have they don't have they don't have Miami doesn't have a lot of green spaces, so all the people that live there suffer of depression, you know, and that's what the ecological study will say. But that's not true because there may be you may live in Miami and you don't have depression. I may live in, you know, in another country that in another city that has high green spaces, and I have this, and I have depression.
Depression. Okay.
You see, so the study is, it just says all the people in Miami, but it didn't really do like a, like let's take a neighborhood in Miami, like this neighborhood that is called, I don't know what's the neighborhood in Miami. Let's call this neighborhood whatever. Let's pick 10 people from that neighborhood, and let's see if that neighborhood has green space. And now let's, no, you just pick the whole Miami city, and they just say no, Miami doesn't have a lot of green spaces, so let's just say everybody there is depressed. So that's the problem with those ecological things, that you don't, the individual people inside the thing may differ from the big analysis that you decided to take. So that's why they're saying that you see C and D, it says an individual living in blah, blah, blah doesn't have whatever. They're talking about the individual. But the study design is ecological. So you cannot talk about the study design didn't talk about
Yes.
the individual. Yeah. So you cannot come and infer that, oh, the individual living in that space has about the depression, because the study is not about the individuals, it's about big counties. I think the thing counties is, that's what is a big thing, because not all countries have counties,
Yes.
but
True.
anyway, yeah, they're just assuming it's the US, so that's what, yeah. But yeah, so that's why C and D, because they are talking about an individual person, one person, and the study is about ecological. And then A is talking about the same thing, the word prevent that we were saying. Prevent, it seems that prevent is like cause, that you cannot use that for, cohort and all these studies. You cannot cause or prevent or whatever. You cannot use those words. And that red thingy was basically telling you, yeah, what I was explaining. You cannot talk about an individual when you did a study about the whole country or the
Count.
whole,
Count.
yeah, the whole state or the whole city. You cannot talk about individual people there. Yeah, I
Okay.
think that was, yeah, was the thing. So up to you. Do you want to continue? You want to stop? It's up to you.
How many questions left?
Oh no, we are in page 15. We have until 24, so we're definitely not going to finish this today.
Okay.
We're definitely going to finish it tomorrow.
So okay. Okay, let's keep it for tomorrow.
Okay, perfect. Then
Oh.
we remember